All right, this is on the second day of quadratic formula, where we want to find the zeros of the function. So we're going to go ahead and set the function equal to 0. And then identify the value of the a, b, and c. So that's our a, b, and c. So the value of the a is going to be 2. The value of our b is 5. And the value of our c is also 5. We're going to go ahead and substitute into our formula. So x equals negative b plus or minus the square root of 5 squared, so b squared minus 4ac all over 2a. So there's the substitution of all the values. And now we start simplifying. So x equals negative 5 plus or minus. We go underneath the radical to the discriminant. 5 times 5 is 25. And then we multiply negative 4 times positive 2 times positive 5, and we get negative 40. And then in the denominator, 2 times 2 is 4. Continue with the discriminant, which is underneath the radical. 25 minus 40 is negative 15. Since our discriminant is a negative, we're going to have two non-real solutions. So I'm just going to come over here and continue simplifying. So now we have that negative, so I'm going to separate this out as negative 1 and square root of 15 over 4. So then x equals negative 5 plus or minus. This will become our I. And now square root of 15, we can't do anything with that, so we just leave it as the square root of 15. And then over 4. There isn't any more reducing that we can do. There isn't any common factors, so we can just leave the answer like that. All right, here's our second example. We want to go ahead and set the equation equal to 0. And then identify the value of a, b, and c. So the value of a is 3. The value of b is 10. And the value of c is 7. We're going to sub it into our formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now we start simplifying. So the negative 10 stays as it is, plus or minus 10 times 10 is 100. And we multiply negative 4 times positive 3 times positive 7, and we get negative 84 over 2 times 3, which is 6. Continue simplifying underneath the radical, the discriminant. So we will combine 100 minus 84 gives us 16. 16 is a perfect square, so we can go ahead and reduce that down to the square root of 16, which is 4. Now I'm going to separate out into two fractions. So I'll call this x sub 1, where we have negative 10 plus 4 divided by 6. I'll do the other one down here, x sub 2, where we want to subtract 4. So negative 10 minus 4 over 6. All right, so let's go back to that pink one. So we're going to simplify the numerator. So negative 10 plus 4 is negative 6 divided by 6 gives that first solution as negative 1. Go back to the red. Simplify the numerator. You get negative 14 over 6. Reduce that fraction down, and you get negative 7 thirds. So there's your two answers. They're both real because our discriminant is a number greater than 0, a positive answer. All right. This is just a summary of the different methods to solving a quadratic equation. One is we can graph it and find the x-intercepts. So here is our quadratic equation, and we can find the x-intercepts right here by graphing it. So here's the two x-intercepts. Another way is we can factor it and use our zero product property. Another way is we can solve by square roots. Another way is to complete the square. And the way that we just finished today is to solve by the quadratic formula. It's a helpful hint that no matter which method you would use is to choose, you'll get the same answer throughout. So any of these solutions do work. Just depending on what type of equation we give you, you might want to choose one of those other methods over the other.